So 0, 1 knapsack. Given a set of items, each having different weights and value or profit associated with it, find a set of items such that the total weight is less than or equal to the capacity of the knapsack and the total value earned is as large as possible. So what is a knapsack? A knapsack is a sack. Sack means a bag or goonie. So given a set of items, what you have to do, you have been given different weights. So different weights are given and associated with that weight certain values are or profits are given. So if there is 5 kg weight, profit associated is 25, say 6 kgs, profit associated is 30, and so on. There are weights and values given. Find a set of items that the total weight is less than or equal to the capacity of the knapsack. So for example, if I say that the knapsack capacity is nothing but 8 kgs. Okay. So you have to find a set of items such that the total weight is less than or equal to the capacity of the knapsack and the total value earned, that is a total profit, is large enough. So if I am saying that 8 kgs only is the knapsack capacity, total is how much? 11 kgs. Out of this 11, you want only how much? 8 kgs. So 6 kg is giving more profit. So you will include 6 kgs and you will say 30 rupees is the profit. You will not take the 5 kg into consideration. So this is nothing but you have to see to it that the profit earned is maximum and it can be equal to or less than. In our case, it is less than the capacity of the knapsack. The knapsack is suitable in solving resource allocation problem. Let x equal to x1, x2, x3 till xn be a set of n items. Set w equal to w1, w2, w3 till wn and v equal to v1, v2, v3 till vn are weights and values associated with the item x. So there was an item x. Weight associated to that item is 5 kg and profit, that is v, this is w, and v associated, I said it is 25 rupees. Knapsack capacity is m units. So I said knapsack capacity, I want it as 8 kg. So 8 kgs is that m unit. The knapsack problem is to find a set of items which maximizes the profit such that the collective weight of selected items do not cross the knapsack capacity. So if you have selected 6 and 5 both, if you select both, then you get 11 kgs. 11 kgs exceeds the weight of the knapsack. So you have to select in such a way that the weight items do not cross the knapsack capacity. Select items from X and fill the knapsack such that it would maximize profit. Knapsack problem has two variations. 0, 1 knapsack that does not allow breaking of item. Either add an entire item or reject that entire item. So when I was given a choice of 5 kgs and 6 kgs, profit associated was 25 and 30. I selected 6 kgs. But I did not select, I rejected 5 kgs because value of profit was less. 6 kgs value of profit was greater. So either you can add the entire item, add the entire 6 kgs or reject it. It is also known as binary knapsack. Fractional knapsack allows breaking of items. So now capacity was 11 kgs. In case of fractional knapsack, what do? I take the 6 kgs, capacity was 8 kgs. I take the 6 kgs and out of this 5 I will only take 2 kgs. Out of the 5 kgs I will only take how much? 2 kgs. So I can break the item up in case of fractional knapsack. But in case of 0, 1 knapsack you cannot break the item. You can either you take the full item, full 5 kg you take, or reject full 5 kg. In our case we are rejecting the 5 kg. So algorithm DP binary knapsack VWM for I equal to 1 to n do V of I 0 you will assign 0 to it, and for I 1 to m, do v of 0 I. So 0 will be assigned to v of 0 I, and for I 1 to n, do for j 0 to m, do if v of I is less than equal to j, v of ij max is v of I minus 1 comma j v of I plus v of I minus 1 comma j minus w of I. Else v of I comma j is nothing but will be assigned what value? V of I minus 1 comma j. Algorithm for trace knapsack, SW is empty, that is the weight profit is also empty. I is n, so n will be assigned to I, m will be assigned to j, while j greater than 0, do if v of I comma j equal to v of I minus 1 comma j, then I minus 1 will be I, else v of ij minus v of I will be v of ij. J minus wi will be j, sw plus wi will be sw, and sp plus wi will be sp. So this is the algorithm. More clear understanding will be when we solve the problem in the next video. Complexity analysis. With n items, there exists 2 raised to n subsets. Brute force approach examines all subsets to find the optimal solution. Hence, running time of brute force approach is big O, 2 raised to n. This is unacceptable for large n. Dynamic programming finds an optimal solution by constructing a table of size n into m, where n is the number of items and m is the capacity of knapsack. This table can be filled up in big O n into m times, same in space complexity. So what is the complexity? Big O nm. Running time of brute force approach is big O 2 raised to n. Running time using dynamic programming with memorization is big O n into m. So complexity for knapsack is big O n into m.